Welcome back to Transcended Institute. In today's tutorial, we are going to look at logarithmic and exponential functions. So in this video, we are going to talk about how to sketch the exponential, how to evaluate the logs, expressing log to exponential, expressing exponential to logs, as well as finding the exact value. We'll go further and also look at how to use the properties of log to express the logarithmic into single quantities. We'll go further and look at the change of the base formulas. We'll look at how to prove these to my simple and interesting questions. And we'll go further and also look at how to solve the equations, how to solve the inequalities of the logs, and we'll go further and also look at the limits. Okay, so I have solved all the questions from this tutorial sheet. If you want to access the full tutorial sheet solution, follow the link in the description below and you'll be able to see the link that has got full video for this tutorial sheet. So without wasting much of our time, let's begin our discussion with the first question. But the first thing that we're going to talk about is basically sketching exponential functions and how to find the domain and the range. Okay, so one thing we have to understand whenever we're talking about sketching exponential function, we need to understand only two things. One, you should be able to remember that exponential function has got what we call horizontal asymptote. Horizontal asymptote, it cuts at y. Y is equal to that number that we're going to be finding. Okay, but sometimes you might be wondering, like, how can you know that this is an exponential? Exponential function is either written as e to the power x, e to the power something, or a number to the power something. That is an exponential. Okay, then whenever you come across log or ln, natural log, this is what we call logarithmic. Logarithm. So this is an exponential function. Now, whenever we want to know how to sketch the exponential function, we need to know only three things, like I've said. The first thing is to know how to find the horizontal asymptote. So the horizontal asymptote is the number that is not attached to the exponential. For example, the first question that we have here, it is f of x is equal to 3x plus 4. The number that is not attached to this is basically 0, so it was plus 0. So therefore the horizontal asymptote in that case is 0. So here the number that is not attached is negative 1. So the horizontal asymptote is negative 1. Here it is this one. Here it is that one. Okay, so now you need to equate the power equal to two things. So you get the power, equate equal to 0, get the power, equate equal to 1. So equate equal to 0 and equate equal to 1. Why are we equating to 0 and 1? Any number to the power 0 is 1. Any number to the power 1 is the number itself. When you do this, solve for x. So now if I shift 4 to go to the other side to be 0 minus 4, therefore x is equal to negative 4. Here it will be x will be equal to 1 minus 4 is negative 3. So I have this x, y. So when x is negative 4 and when x is 3, negative 3, what will be the value of y? Y is equal to 3 raised to the power negative 4 plus 4. That gives me 3 raised to the power 0. Y is equal to 1. So there is 1. Next, y will be equal to 3 raised to the power negative 3 plus 4. Then y will be equal to 3 raised to the power 1. So any number to the power 1 is the number itself. So there I have 3. Once you come up with this coordinate, believe me, this is going to be easy for you to sketch. Now when you do that, come up with a simple sketching. Okay, so now I have in x I have got negative 3 and negative 4. In y I've got 1 and 3, so I've got 1 and 3. Now the horizontal asymptote, it is cutting at y is equal to 0. Y is equal to 0, it is at this line. I'll put a dotted line to show that that is the horizontal asymptote. Now we can have the coordinate negative 4, 1. Negative 4, 1 is basically here. Then negative 3, 3 is there. We have got two lines, we have got two dots. So the line should start closer from the asymptote, then coming down like that, touching these two lines, going like that. Then you put an arrow. This is the graph of f of x is equal to 3 raised to the power x plus 4. Now let us talk about the domain and the range. If you look at the domain, we're talking about the x values. Where it is coming from we don't know, and where it is ending, it is just it keep on going. It will go to keep on going. We don't know where it's going to end. Therefore, the domain of any exponential function, it is from negative infinity to positive infinity. Done. Okay, what of the range? The range is always restricted. So the range starts with the asymptote going to where the graph is going. So in this case, the graph is going toward positive y-axis. So then, starting from 0, not included because we are not including it, just starting closer from the asymptote, going to positive infinity. So that's what you need to understand. Okay, after doing that, let us go ahead and also look at another question, which is question B. So question B is saying, remember, the goal is to find, the first thing is to find the horizontal asymptote. Horizontal asymptote is the number that is not part of the exponential. In this case, is negative 1. So horizontal asymptote is negative 1. Equate the power of the exponential equal to two things. Equate the power equal to 0, equal to 1. So for x is equal to, if I divide both sides by negative 1, 0, x is equal to negative 1. Now let's find the coordinate. This is x, this is y. When x is 0 and when x is negative 1, but I can start with negative 1. You can start with any anyway. Negative 1, then 0. When x is negative 1, y will be equal to 4 raised to the power negative 1 minus 1. Y is equal to negative 1 times negative 1, so it's 4 raised to the power 1 minus 1. Y is equal to 4 to the power 1. Okay, 4 to the power 1 is what? Is 4. So 4 minus 1 is 3. So this one give me 3. What if we put 0? If we put 0, it's going to be 0 times negative is just 0. So y will be equal to 4 to the power 0 minus 1. Y will be equal to 4 to the power 0 is 1 minus 1, 0. So that becomes 0. After doing this, I can now come up with my graph. My horizontal asymptote is at negative 1. I'll put negative 1 here and cut a line. Once I do that, another thing that I have to do is x is negative 1. So I'll put negative 1 here, then and 0. Another thing, in y we have got 3 and 0. So 0 is here, then I have got 3 here. Let's see, negative 1 comma 3 is there. Okay, then another thing that I have is what? 0 comma 0 is there. What does it tell me? It tells me to say, now this curve, they can even tell you to say, in this case the graph can't start like that because it has to touch two lines. So the graph will start from closer to the asymptote, going this side and touching those two. That is my graph. Now what is the domain? Like I said, the domain of any exponential function is from negative infinity to positive infinity. We don't know where it is ending, we don't know where it started from. Okay? Then the range is always restricted. So the range will always start from the horizontal asymptote. So in this case, since it is starting from the -1 all the way to positive infinity, not included. You guys pause the video, try to solve part 3 and compare with the answer that I'm going to find. Okay, so let's go ahead. The power, remember the horizontal asymptote is the number that is not part of the, so 3 is part of the asymptote, it is part of the exponential because it is just in the brackets. Okay, so horizontal asymptote in that case it is -3. Equate the power equal to two things. Equate the power equal to 0 equal to 1. Therefore x is 1 and x is -1. So when x is -1, sorry, x should be 0, the first one. Okay, when x is -1 and when x is 0, what will be the value? Y is equal to 3 open brackets 3 raised to the power, when x is negative, so negative times negative, it will give me 1 minus 3. Y will be equal to 3 to the power 1 is 3. 3 times 3, 9. 9 minus 3 again should be 6. So this gives me 6. Y is equal to 3 open brackets 3 to the power -0, which is just basically 0, minus 1. N number to the power 0 is 1. 1 times 3, 3. 3 minus 1, which is outside, that gives me what? So 3 times 1 minus 1, that gives me 2. So I have got 2. After getting my 2 coordinate, I can go ahead and now sketch my graph. So there we go. We can clearly see that we have -3, so I'll cut the line. Okay, I'll cut the line. Another thing that I have is -1, 6. So now in x I have -1, in y is 0, so then again in y I have got +2 and 6. So then when I do this, I can now have the my coordinate. So I can clearly see -1, 6 is here, 2, 0 is there. Once again, we can clearly see that the nature of the graph is going to be the same, for the fact that here there is negative, then here there is also negative, and then it is also raised to the power negative. So it will be the same. So this is going to come like this. Starting from the asymptote, touching these two guys, going there. That is the graph. Now, what is the domain? Try to pause the video, find the domain. The domain is from -infinity to positive infinity. The domain for exponential doesn't change, but the range is restricted. So the range in this case is going to be what? The range in this case is going to be starting from the asymptote, -3 to positive infinity. It is just a coincidence that the range is always going to positive infinity, but there are some cases where the graph is going down, then it has to go to negative infinity. Okay, so I want you guys to try sketching at G and tell me the domain and the range in the comment section. I'll be able to see it and I'm going to respond to it. Okay, so now let us look at another type of exponential. which involves e. So even here we can clearly see that it's basically the same. We have got the same nature of the graph. Nothing is going to change. Yeah. So we have the first one, that is so you always, now the horizontal asymptote there, it will still be 0. There is no number that is not embedded to which is after the exponential, like I said. Then after doing this, one thing we should be able to know again is that we are going to equate 2x minus 1 equal to 0, 2x minus 1 equal to 1. So for x, if I shift 1 to go to the other side, I'll do it from here. 2x will be equal to 1 divided by 2 divided by 2, x will be equal to half. That will be the first coordinate. So x will be equal to 1 over 2. Now 2x minus 1 is equal to 1. So 2x will be equal to 1 plus 1. That gives me 2x is equal to 2 divided by 2 divided by 2. X is equal to 1. Let's go ahead and find the values of y. The value of e, I want you to understand one thing. The value of e is approximately 2.7. I don't know if it's 41, or it's 41 or 14, but just know that it's approximately 2.7 something. So then we'll say y is equal to e raised to the power 2, where there is x we put half, minus 1. Y will be equal to e, 2 times half is 1. So 1 minus 1 is 0. E, any number to the power 0 is 1, so this is 1. Y is equal to e raised to the power 2, where there is x we put 1, minus 1. That gives me 2 minus 1, which is e to the power 1. Any number to the power 1 is the number itself. So you don't have to replace e with 2 point something, no, but you should just keep in your mind that e is approximately 2 point something, 2.7 something. Okay. Now using this, I believe you guys can go ahead and sketch using the previous example that I gave you. Okay. So let's go ahead and now sketch. Okay. Let's go ahead and sketch. So then if I want you just to keep in your mind that e is approximately 2.718. Should be 18, but I know that is 2.71. After 1 I don't know the number, but it should be 8. So just keep in your mind that is 2.7 going that side. Okay. So that one we should know. Another thing that we should be able to know again is the reason why I want you to know the value of e is how you are going to replace the values of y. Which number is bigger between 1 and e? It's basically e. Okay. So then the horizontal asymptote is at 0. I'll cut the line here. So when x is half and when x is 1. So when x is half and when it's 1. So y is 1 and e. Now we are going to have our coordinate half comma 1 is here, 1 comma e is there. Starting closer from the asymptote, touching these lines, going there. You put an arrow because we don't know where the graph is ending. From this we can clearly see that the domain will not change, negative infinity to positive infinity, because we don't know where it is starting from and we don't know where it is ending. It can keep on going. It can keep on going until all the way to East Park here. Okay? But the range is restricted. The range starts from the horizontal asymptote to where the graph is going, starting from 0 all the way to positive infinity. Using this concept, let us go ahead and look at another question. So here I'm going to leave 2 for you. I believe you can sketch this one. Okay, let me sketch this one and this one, then I'm going to leave this one for you. Okay? So we have negative e, the horizontal asymptote in that case is 1. That's the number that is not embedded to the exponential, is 1. So this is equal to 0 and negative x is equal to 1. So therefore x is equal to 0 and x is equal to negative 1. When x is equal to 0 and when x is negative 1, what will be the value of y? Y will be equal to e raised to the power 0, because negative is not going to affect anything. Any number to the power 0 is 1. 1 plus 1, 2. So that gives me 2. E raised to the power, I put negative 1 plus 1, that gives me 1. So we have got y is equal to 1 to the e to the power 1 is e plus 1. So e, you don't know what e, we don't replace e with the number because we're not using a calculator. So I would say e plus 1. But initially, basically that is 3.71 something. Okay? We leave it like that. Let us go ahead and sketch. In x we have got neg 1 and 0. In y we have got 2. We have got 2 and e plus 1. Then the horizontal asymptote is at 1. So I'll cut the line like that. But to make things simple, I'm going to shift this side, so that I extend this part this side, like that. Now I can clearly see that I have got 0, 2. 0, 2 is there. I can use a different color. Negative 1 negative 1, e plus 1 is there. Starting from the asymptote, we can clearly see touching these two guys, but the graph has to be neat. But anyway, sketching. So this is the graph. Now what is the domain? The domain is from negative infinity to positive infinity. Like I said, it's not going to change. The range is restricted, starting from the asymptote to positive infinity. Now I'm going to sketch the last part, then you guys go and sketch part 3, send me the answer, and write the domain and the range in the comment section. Now let us look at the last question. So now here, when we want to solve this, we should be able to know that this is an exponential. Again, this is an exponential. So then this one, there is no need of us considering the horizontal asymptote. So we're not going to consider any horizontal asymptote because we don't, it's just exponential. So, and then it is squared again. So at the same time, when it is like this, just equate this equal to two things, 0, 1. You want to find the value of x. X is equal to 0 and x will be equal to, now we have to get the square root here. So x squared 1, so you say plus or minus the square root, this and that will cancel. X is equal to plus or minus 1, meaning that I have got three values when x is -1, 0 and 1. Then now let's find the values of y. Okay, so y is equal to e raised to the power x squared minus e. Y is equal to e. X is basically -1, but -1 squared is 1 minus e. So e minus e is 0. So what I have for negative, it will be the same as for positive. If I plug in plus, it will give me still 1. So e to the power 1 is e. If I plug in 0, n number to the power 0, 0 squared is 0. So n number to the power 0, that becomes e to the power 0, then 1. 1 minus e is just 1 minus e, like that. When we do that, we can go ahead and now look at the graph, the nature of the graph which we are going to have. If we look at this, e minus 1 is approximately, we said e is approximately 7 or 2.718. So then 1 minus e is the same as negative, so it will be here. It's the same as negative, so e minus 1. Then you have got -1, we have got 1. If we look at this, -1, 0 is here, 0, 1 minus e is there, 1, 0 is there. So the nature of the graph will be going like this. It comes there, it touches these two, then it goes there. So you put the arrows because you do not know where the graph is ending. Okay? So this is the graph, the nature of the graph. Other people will tell you to say, but this is the best graph for this equation. Other people will tell you to say, they will assume that this is the horizontal asymptote. So when they do that, negative, it will bring to them like this. So it goes there, it goes there. But the best graph, because both are exponential, is this one. Okay, perfect. That's the graph. So that is it about exponential, sketching exponential functions. I hope you have learned something and try to explore different type of questions, try to solve them. Yeah, so I believe you are enjoying this video, but before we continue, I want you guys to know that you can access all our videos, our throw sheets solutions, the past paper solutions, as well as the full topic videos. So if you go on our website, you'll be able to see the courses that we have, or the courses for natural sciences. So I'll show you the one for math, and you should be able to know that your exam is just covered with the throw sheet and the past papers. So we have solved all the throw sheet solutions. You can clearly see here we have for 2025, 11, 20, 1100, and of course these are the throw sheets. Okay, and also some past papers for 2023 and 2024, as well as test papers. Okay, so now I want you guys to, if you want to register with Transcended Institute, just go on Google or Chrome, just type Transcended Institute. The website is going to come, register with us, or use the link in the description below, and you'll be able to access these videos. We have everything for the same: chemistry, mathematics, biology, as well as physics. So physics, I think you are aware that for you to prepare much, you need to go through past papers, and I've solved a lot of past papers for physics, both test and exam. So they are going to help you. Register with us. There is a promotion which is running right now that can help you to register almost for all the courses. Okay, back to the business. So let us talk about the basic rule of logarithmic. So there are a few things that we need to understand under logs, and this is what we call the basic rules of logs. If at all you have log base c, let's say base a of x to the power n. The property of log allows me to shift the power to be in front, so this becomes n log a of x. At the same time, I can shift this to go as the power. Another property is log base a of a is 1. So log of base itself is basically 1. Okay? Then another property that I want you to understand is that log, if there is no any base, it is in base c 10. Same applies to ln. Natural log of ln, it is always in base e. Okay? So then you should note that ln e, if the base is e, that is the same principle with this one. So the base of ln is always e, then the answer for this guy, it is just basically 1. Okay? Another property that we need to understand is regardless of any base, log 1 is 0. Same applies to ln, 0. So the answer for this guy and this guy is 0. These are the properties that you need to understand. Ln 0 is undefined, log 0 is undefined. Log negative is undefined, ln negative is also undefined. So the properties of ln and log, they are basically the same. We're just talking about the same logarithmic functions. So these are the basic rules that we're supposed to understand. Okay? Now we can use these basic rules to evaluate what we have. Okay? So let us start with the first question. I mentioned to say log, if there is no any base, then it is in base what? It is in base 10. So I need to make the base and this guy to be the same, so that I should apply this law. So then I can say log 1 over 10 is basically the same as 10 to the power negative 1. After reaching at this point, I can now apply the first property. The property of log allows me to shift the power to be in front. So that becomes now negative log 10. This is log base 10 of 10 is 1. Negative 1 times 1, negative 1. That's the answer. Let us go ahead and look at question 2. Log, anything in the square root is the same as raised to the power half, in case you don't know. The property of log allows us to shift the power to come in front, so negative half log of 10. As long as the base has not been indicated, it is in base 10. Log base 10 of 10 is half. Done. So the answer there is half. Let us look at the last one, which is natural log of 1 over e to the power 3. It's basically the same principle. So it will be ln e. To remove this one, we want to make the base and what is inside to be the same. It will be negative e. So here, remember, there is an invisible e, that is the base. The property of log allows us to shift the power to be in front. That becomes this. Ln e is the same as this one, which is 1. So now negative 1 or negative 3 times negative 3 times 1 is negative 3. That becomes my answer. So that is the general idea behind this guy. But using the same concept, I want us to go ahead and also look at the certain question, that is this one. So we are going to use the same concept now to look at this one, which is question 6 in this case. So we are using the same properties. Okay, the property that we said, I'll just rewrite them here. We said log of a x to the power n is n log a x. We said log of base itself is 1. Same applies to ln, if at all you have got ln. Then another thing is Which other properties were we talking about? We were also talking about if we have got log of 1, that is 0, then log of 0 is undefined. So these are the properties I want us to use. So ln is always in base e. Log, if they have not indicated the base, it is in base 10. Now if we look at the first one, it's just a matter of us making the base to be the same, okay, making the base to be the same as the so we're making the base to be the same as the what? We're making the base to be the same as this guy on top there. I've used the white color, but this one. So log base 2 of 3 to the power is 64. 64 can be written as 2 to the power 6. Not so. So log 2 to the power 2, the property of log allows me to shift the power to be in front. That becomes 6. So 6 log base 2 of 2 is 1. So 1 times 6, 6. Pause the video, try to solve part 2. If I go to this, it's basically the same thing that we have been doing so far. Log base 2 of 1 over 8, it can be written as log base 2 of 8 to the power negative 1. So log base 2 of 2 to the power negative 3. Negative 3 can come in front. So negative 3 is the answer. Now I'm going to look at, you can do the part 5, the one for 1 over 27. Send the answer in the comment section. I'll be able to see it. And then ln is basically the same of the one we are solving actually. So guys, go ahead and solve this one because it's basically the same as this one, the one I solved here. So go ahead and look at that. Okay. After looking at this, I want us to also look at how we convert the exponential to log at the same time, from log to exponential. So I'll give you a very simple example. Let's say we have got log x of y is equal to 2. So this is how we read: log base 2 of y, not log x to the power y. No. Log base 2 of y is equal to that. So now we are going to look at this. I want you to understand that this is basically the same as x raised to the power 2 is equal to y. So the base raised to the power what is outside is equal to what is inside. Okay, interesting, right? Let's solve part 1. The base is 2. Put the base here. What is outside is 4 raised to the power 4 is equal to what is inside is 16, and this is true. 2 to the power 4 is 16. Interesting, right? If the base has not been indicated, then it is in base 10. So the base is 10 raised to the power what is outside is equal to what is the inside. 2 to the power 2, 10 to the power 2 is indeed 100. This is always in base e. E raised to the power what is outside is 1, negative 1 is equal to 1 over e. E to the power negative 1, in short here we have converted, but we should know that these are the same. There is 1, you can remove 1 on top and put as negative. Let's try this one. E, that's the base, raised to the power what is outside is 3 is equal to x plus 2. Done. So that's how we convert now from exponential, from logs to exponential. But again, we can use the same concept. Okay, we can use the same concept again to answer this. So now here we are coming from exponential to log. So remember, I will just go back to this. I'll give you an example of the first question that we were looking at. So the first question we said it is 2 raised to the power 4 is equal to 16. So you can clearly see that log, you just write log, this is always the base 2. What is the power is what is outside. What is outside here is what is inside. I'll carry this and use it for the next question. So here, what this guy here is becomes the base. So this is always the base. Okay, then what is the power becomes what is outside. What is outside becomes in here, like that. So here, if I want to change again using that concept, it is 3 raised to the power 4 is equal to 81. I've gone back there. So it's basically the same thing. So here, if I want where there is e, I'm going to be using ln. Okay, so I'll say ln, the base, this becomes the base, so it is e. Okay, it is always in base e, that one we know. So it is always in base e, but it is invisible. I'm not going to include it. Y is equal to 4. If I want to convert this to exponential, I know that the invisible is base. The base is e raised to the power 4 is equal to y. Not so. Go ahead and look at that one now. This is going to be the same. Ln, e is not going to appear because that is invisible. We know that ln is always in base e. Then 5 will be here is equal to x. If I want to change again, is e raised to the power x is equal to 5. Again, it's the same with that. Next, as long as there is e, you have to use ln. If there's no e, you use log. In this case, I'll say log. This is always the base. Now, if it is in base 10, we don't include the base. Okay, we don't include the base. So this will be equal to, what is the power is what is outside. What is outside here is what is going to be inside, like that. If I want to change again, is 10 raised to the power this is equal to y. Interesting, right? Yeah, so pause the video, try to solve part 5, send me the answer in the comment section. I'll be able to see it. Yeah, so these are the basic rules that we're supposed to understand under log. Okay, let us go ahead and also look at how to express let us go ahead and look at how to express logs into single quantities. So there's some few things that we need to take note. If we have got log, the base is the same, log a plus log b, provided that the bases are the same, then you multiply what is inside, so it will be log a times b. So if I've got log a minus log b, provided that the bases are the same, then we can divide this. The part having positive will be on top, b will be down. So this is the principle that we're going to be using. Okay, but remember, these are supposed to be the same. Log in front, there should be nothing in front. Let's begin our discussion with the first one anyway. So this one, log, the base is the same, we can multiply, so the base is the same, then it's just telling us to say it is x squared times 1 over x. But x squared times 1 over x is the same as x squared divided by x. X squared is the same as x times x divided by, we have put this x down, so 1x can go. So therefore log will be, this is the single quantity now. I've expressed it. Using the same concept, pause the video, try the second one. So log base 3 of 9 plus, the property of log allows us to shift the power to become, to the guy which is in front to become the power. So that becomes 2 to the power 3. So log 3 9 plus log, the base is 3. Now this becomes 8. Provided that the base is the same, you rewrite this, then you multiply now this times that. So it's 9 times 8. It's not a point, guys, it's times. So 9 times 8, it should be 72, but I don't know. 1 2 3 4 5 6 7 8. Yeah, it's 72. So 72, that's the answer. If I look at the second one, the third one, try to pause the video, try to work it out, then we can clearly see that we have got log or ln y. The property of log allows us to shift this to become in front, or to become as a power. So it will be power 4 minus log 4. The bases are the same, so you write ln. The part having negative will be on the denominator, so that is the answer. This applies the same with what I have there. For them to have 1, remember the properties that we have been doing so far. Remember, for them to have 1, then it was ln e. So that's what we need to know. So it is the same as 2 ln 6 minus ln e. Ln e is 1. So I'll shift the power, this guy, to become the power 6 to the power 2 minus ln e. So ln 36, because 2 to the power that is that, so ln e. So here ln e. Now that the bases are the same, we'll just say ln, the power is invisible. Now that the base are the same, then this 36 will be on top. I will divide here by e. So then I've changed now to a single quantity. So this is the basic idea behind expressing log into the single quantity. Okay, let us look at change of base formula. So how do we tend to change the base? So I'll start with so the formula goes like this. If we have log a of b and we want to change this to base c, so you write log, write this b here, divide it by log, write this a here, and I want to change this to base c, then you just put c there. So I've changed from log base a to base c. Simple, right? Using the same formula, the question here they are saying use the change of the base formula to prove the following statement. So here we are proving that this is equal to that, so we are going to start with this part. So I'll just write log using the formula. Okay, I'll write the first one is a, then I divide log, then b. Now you look at what you are trying to prove. Now they are changing this to base a, so you put a here, a. Remember, log base a of a, log of base itself is 1. So therefore the top part becomes 1, the down part becomes like that. So this is exactly as that. Okay, now let us also look at this. They are saying that show that that is equal to this. Remember, log and ln and natural log, they are basically the same. So here they have just changed this to ln. So what we should remember is that the formula remains the same. So here the base is 10. So you are writing log. So instead of writing log, we are going to use ln. So we'll say ln. Now we'll leave a space and put e. Okay, we'll put e. So now here they are changing to base e. Then you divide it. Then here you put also ln. The base here is 10. So you are changing to ln. Ln is always, you are changing it to base e. So you put e, you put e. So you can clearly see that ln e is 1. But ln e of 10, we don't know what that is. So we just put like that. So this is exactly as that one. Now I'm going to give you some more practice questions under this subtopic of changing of the base formula. Let's say we have log base 9 of 2. Let's change this to base 3. pause the video, try to use the formula and come up with the answer. So log, you write 2, you leave a space, then log, you write 9, you leave a space. Remember, want to put base 3, put 3 here, put 3. Now the down part can be simplified further. Log base 3 of 2, 9 can be written as 3 to the power 2. The property of log allows us to shift the power to come in front. So what happens? We'll have log base 3 of 2 on top, then 2 log 3 of 3. Log base 3 of 3 is 1. So this simplifies further to be 2 times 1, which is just 2. But this can be written as 1 over 2 log base 3 of 3 over 2. Oh, can be written as this is log base 3 of 2. Why am I writing it in this way? If you have got x plus 1 divided by 2, it's the same as 1 over 2, then x plus 1. It's basically the same thing. Now it will not end there. The property of log allows us to shift the power, what is in front, to be the power. So this goes further, and it's going to be like this. When something is raised to the power half, it's the same as the square root. So I've changed now from base 9 to base 3. If you have gotten that, can you go ahead and solve this? Log base 8 of 9, change this to base 2. Another one which I'm going to give you is log base 27 of 4, change this to base 3. So go ahead and do this. Type the answer in the comment section. I'll be able to see them.